Okay guys, we'll start solving this numerical which is based on the principle of superposition. So let us consider this three pieces of material which are all made up of steel only, but suppose if there was only one load acting throughout, then we would have solved it in single equation. Since there are multiple loads acting at different sections, we have to divide this into three sections: section 1, section 2 and section 3. So to understand what is the load acting on section 1, so we have to understand each of these elements and the load acting only on them. So let us consider section 1. So if I see section 1, you have to just see what is the load acting on the left hand side of the section 1. If you see the, now what is the load acting on the left hand side of the section 1? 7 kilonewton. And if you see, I think once it is done, you don't have to see what is the load acting on the right side. You can just put it as 7 kilonewton. But you may be worried why I am putting this. Of course, you will see that here I can explain you why this is like this. So most of the times the loads which are tensile is called as positive. This is positive. And loads which are compressive are negative because they will actually decrease the length. They will decrease the length. So this is positive. Whatever is actually trying to decrease the length, which is compressive forces, are negative. So this is positive. And on the right hand side, I have written it as 7 kilonewton without thinking. So you can do that in the examination. But you need explanation why I have done this. You can see that this right side of this one is actually applied the force which is minus 8 kilonewton, which is compressive. And then this force which is applied, I gave the example. One guy actually pulled this and the shoulder got dislocated. So that means if you, even if I apply a load of 5 kilonewton here, that 5 kilonewton would definitely get applied onto even one also. So this is plus 5 kilonewton. And then this 10 kilonewton will also get applied onto this part one. So this is plus 10 kilonewton. What is it now? 15 minus 8, which is 7 kilonewton. So in the examination, you don't have to check every time. You can directly write. So that means if one side if the force is 7 kilonewton, on the other side it will be 7 kilonewton. You can directly write this. So this is the load acting on element 1. So you know the formula for the elongation of this one. You can definitely use this. So dl1 is equal to P1 L1 A1 E1. So you can substitute these values here. Okay, I'm doing it ulta, sorry. So now what is the load acting here? 7 into 10 to the power of 3 newtons multiplied by L1, which is 100 mm, divided by AE. What is the area? Area, I set it as 100 mm square. I set it as 100 mm square. And E is, I given it as 200 GPa. I think all the sections are steel. So 200 GPa can be transferred 200 into 10 to the power of 3 Newton per mm square. So we can find out dl1. So you get some answer here. You cancel out this mm square, and you cancel out this Newton. What is left is actually mm. So what is the answer? 35 mm. 35 mm is a large. 35 mm means for every 100 mm, if it is elongating by 35% elongation. 0.035. Usually you get very small numbers. Guys, usually you get very small numbers because yesterday we said, no, for even 1 meter length, steel can only elongate by half mm. So usually you don't get large numbers. Please think, if by chance if you are getting large numbers, somewhere you have gone wrong. So what is the answer you said? 0.035 mm. Okay. So up to around 3 decimal points we can write 0.03583. You don't have to write. Okay. At least 3 decimals is okay. dl1. And this 3. Can you see the section 2? And you see the section 2 here. Section 2 which is here. I am drawing it here. Now what are the loads acting on the section 2? If I consider the section 2, what are the loads acting on the section 2 on the left hand side? 8 and 7. So I will first draw this like this. The first thing that I do is draw an arrow like this. Draw an arrow like this. Even if it is compressive also, I'll draw an arrow like this only. Okay. And then on the left hand side it is plus 7 plus 8. 15. So this is 15 kilonewton. And on the right hand side it is 5 plus 10. So obviously once you write 15 kilonewton, even without checking you can write 15 kilonewton on the right hand side, because the examiner would take care that the forces going to the right side will be equal to the forces going to the left side, because this has to be in static equilibrium. Okay, so 15 kilonewton. So once it is known, then again a similar formula could be used. What is the formula? dl2 is equal to, so p2 l2 a2 e2. No, not a big change. Okay, so it is always better. Sometimes some people do like this. Some people do like this. DL1, sorry, DL they call it as DL1 plus DL2 plus DL3. So they put this as P1, L1, A1, E1, and P2, L2, A2, E2, and P3, L3, A3, E3, and then they will write E1 is equal to E2 is equal to E3, because all are steel only. This is also steel, this is also steel, this is also steel. So since all these are steel only, so they will call it as, this is Young's modulus of steel. So then they will write this like this, 1 by Es is equal to like this. So P1 L1 by A1, something like this. Okay, in this, suppose if you solve like this, then what happens is that you are trying to solve the problem in a single step. In a single step, directly the answer comes here. Directly the answer comes here. Now if the answer is right, examiner will give you full marks. Suppose if the answer is wrong, the answer may be wrong because of this calculation. The answer may be wrong because of this part of the calculation. The answer may be wrong because of this part of the calculation. Answer may be wrong somewhere here. But you will lose full marks because you have solved the problem in one single step. If you solve in different steps, suppose if it is given one step is wrong, at least for the other step you will get marks. So don't solve like this. Don't solve like this. It may look easier, but it is better be safe. Okay. So we can actually, we have found out DL1. We have got an answer. For this we get around 30% of the marks. The second one, DL2. Substitute these values here. So what is P2, guys? 15 kilonewton. Instead of 7, you write it as 15 into the power of 3 newtons. Multiplied by 80 divided by what? 100. Guys, here along with the S, we could have also taken A outside. Sorry, here we could have taken A outside. So it will only become P1, L1, P2, L2, P3, L3. ಇಲ್ಲಿ ಯಂಗ್ಸ್ ಮಾಡಲ್ ಇಲ್ಲಿ ಏರಿಯಾ ಕೂಡ ಸೇಮ್ ಇದೆ. ಇದೇ ತರ A1 is equal to A2 is equal to A3 is equal to A ಅಂತ ಬರ್ಬಿಟ್ಟು you can take this A and D outside and you can solve it easily. So calculations easy ಆಗುತ್ತೆ. But if you go wrong, the answer would be wrong and you lose full marks. But if you are confident, you can definitely do that. So E, Young's modulus of steel, which is 200 into 10 to the power of 3 Newton per mm square. Now what is the answer, guys? 0.067. And once you have done this, people can definitely do this. ಇದು ಹೇಳ್ತೀರಾ ಹೆಂಗೆ ಅಂತ ಎಕ್ಸಾಕ್ಟ್ ಇದರ ಕೆಳಗಡೆ ಬರೀರಿ, ಬರೆದ್ರೆ ಒಂದು ಫೀಲ್ ಸಿಗುತ್ತೆ ನಿಮಗೆ. ವಾಟ್ ಇಸ್ ದಿ ಲೋಡ್ ಆಕ್ಟಿಂಗ್ ಆನ್ 10? So on the right side it is 10. On the right side it is 10 kilonewton. On the left hand side, you can definitely write it as 10 kilonewton. The same step repeats. The same step repeats here. So DL3 is equal to DL3 is equal to P3, L3, A3, E3. So the load is 10 kilonewton, 10 into 10 to the power of 3 newtons. L is actually 120 mm. And A is again same. 1 mm square, and then this is E3 is 200 Newton per mm square, and you get some answer here 0.06 mm. So finally they would ask the old deformation, they would ask find the DL. So DL refers to total deformation, which is the sum of deformation of each of these parts. So DL is equal to DL1 plus DL2 plus DL3. So you add up all this. So first is actually 0.035 plus 0.06 plus 0.06 0.155 that is DL. Guys, suppose if this one is given as steel, other is given as copper, the third one is given as aluminium, where and all you need to make change? Young's modulus. So Young's modulus of steel, DL1 will remain same, 200 GPa, and in DL2 instead of 200, so since it is copper, it will be 100 GPa. So it will be 100 GPa, and it is aluminium, it will become 70 GPa. So like this, you can create n number of problems, sir, having different combinations. Okay? And then the next time they can even reduce the section here. This center steel, aluminium, sorry, copper and aluminium, and here they may give it as the area. So the area may be given as around 60 mm square. So then you can enlarge it. So instead of 100, 60. So you have to make it as 60. So like this, whatever the problem comes, you have to play that way. Okay? So be careful. So this is easy.